All right, here we go with the second half of Chapter 6, Worksheet A. So starting off with number 10. So we got arithmetic series. First one, just asking how many terms are in the series. So based on that, and again, they're just calling it a series because there are plus signs and minus signs separating the terms, but since they're just asking for a specific number of terms and we don't know the sum, we can just use the U of n formula to figure that one out. So arithmetics, we got our U of n formula. So we can just start plugging into that. One thing we're trying to figure out is the number of terms, which is going to be whatever term number he is. So the value of that term is negative 75. So we know the negative 75 goes in for the value. We got our first term of 324. Oops. Good enough. And then get your n minus 1. Common difference, we can see these are going down by 3, which means our common difference is negative 3. So now we just solve that equation for n to get our number of terms. So the usual algebra, subtract the 324, divide the negative 3, add the 1, and looks like we got a number of terms of 134. And then the follow-up question, so now that we know there are 134 terms, now we can figure out the sum of those 134 terms. So now we're jumping into the S of n formula for arithmetics. And we know it's the sum of 134 terms. So remember, we're always just tapping into the formula sheet for these guys. There we go. So that was the first formula that we used for arithmetics. We're now looking for a sum. You got two options here. The short one is available because we know there's 134 terms and we know the value of that term, that last term. We know it's negative 75. So you could just take the short route at this point. This works too. It always does. So, but I'm just going to take advantage of the short one for now since we can do it on this one. There we go. So for this one, we got the n over 2, and again we know there's 134 terms. And then we got the first term, which is 324. And then the last term, or the value of the 134th term, is negative 75. So he can go in right there. And then just a little cleanup on that in the calculator, and that'll get you your sum. So moving on to number 16. So now we have a geometric series. We know the first term and the common ratio, so find the fifth term. So this one's just pretty straightforward use of the formula. So using the U of n formula for geometrics, looking something like that. So find the fifth term. So looking for U of 5. So we know the first term is 7. Got a common ratio of 3/2. And then since it's the fifth term, we're going to do 5 minus 1, which is the fourth power. So that's just a straight shot into the calculator from there, which is about 35.4375. Remember, on a test, standing directions will always be you can write your answer in exact form or 3 sig figs unless the directions say otherwise. So if it's exact, that's fine. You can leave it with a lengthier decimal, but if you're ever going to round, it's got to be 3 sig figs unless the directions say otherwise. So make sure you always follow those. So part B now, the sum of the first 12 terms. And now, so here's one that comes with some special set of directions. So answer to 2 decimal places, so 2 numbers after the decimal. But sum of the first 12. So just using the geometric sum formula, and we're looking for the sum of the first 12 terms. Remember, on this one for geometric sums, there are 2 ways of looking at the formula. There's this way and there's this way. I always encourage this method of writing it. It's safer with the negatives and the exponents going into the calculator, so I'm going to model it after this one. It's a safer way to go. So we got our first term We got our common ratio, and we're looking for the sum of 12 terms. So that's what our setup should look like. You know, on a test, you always want to show your work. In case the answer comes out wrong, maybe you put this incorrectly into your calculator. You can always get points for a correct setup. So make sure you always show the work on those. But anyway, that should be a straight shot into the calculator. When you do this, make sure you put parentheses around the fraction. If you try to do the entire thing in your calculator in one shot, just be careful. If so, you do need to put the denominator in its own set of parentheses when you do that in your calculator in order to get that one right. So just make sure you put that one in correctly. So moving on down to number 18. So last two here. So now we are looking at the infinite geometric series. Slide that up real quick. We know it's infinite for a couple reasons. One is the ... so we know this thing goes on forever. Also, they don't give us a sum of a specific number of terms. It doesn't say find the sum of the first 12 terms or something like that. It just says find the sum. So it would only apply to an infinite series in this case. But again, quick look at the formulas. So here, right here, you got the infinite sum. This is only doable if the common ratio is between -1 and +1. So that's what this is telling you right here. If your common ratio is outside of those boundaries, then this formula doesn't work, and it's just not possible to do that. So for this one, just doing the first term over 1 minus r. So in this case, we just got to identify the common ratio. Do keep in mind, if you're ever unsure of the common ratio because of the setup, like on this one, you can tell they're multiplying the top by 3 and the bottom by 5. So -3/5 is going to be our value for that one. But if you weren't sure, you can always do any term divided by the previous term to get the common ratio. That would be consistent all the way through. So you can do that with any two consecutive terms. But on this one, we can see that it's -3/5 since those signs are alternating. Same thing with something on this. If you try to put the entire thing in your calculator in one shot, you got to be careful with parentheses to play it safe. You should always wrap fractions in parentheses, and you should always wrap your denominator in parentheses. If you're going to do all that in your calculator in one shot, it should look like this, just to be safe, to make sure that you're doing it correctly in the calculator. Alright, so put that one in correctly, and that should get you the right answer. Alright, moving on to the last one here, number 19. So we got an expansion going on. So in the term that has the x to the 4th power in it, could be expressed in that format. So figure out the values of p, q, and r. So remember, we do have a formula for binomial expansion, and it is in your packet. It's right down here next to binomial theorem. Probably the best view of it is this right here. Sorry, let me see if I can highlight what matters. Oh, I'm having a hard time. Anyway, so this guy right here is the formula that we have. So notice that n is the exponent on the binomial. And then the a term and the b term. So the first term within the binomial is your a term. The second one is the b term. And then r we got to figure out. So let me just write that one down, and then we're going to go through it on our page here in a second. So we got the n choose r, and then you got your first term to the n minus r, and then b to the r. So going back to what we have in our expansion, so again, we know that we have a 10th power, so this is going to be 10 choose something. We just got to figure out that r value. The a value is 2x to the n minus r. So again, just got to figure out that r term. And then you got your b term, which is -3 to the r. So we just got to figure out what is r so that we can get all the numbers in the right places. So keep in mind within this setup, they told us right here that they want the exponent to be a fourth power, which means I need this to come out to be a 4. So in that case, we would say, well, what is r? So that I can have 10 minus something to create a fourth power. So that tells me right there, r has to be 6, so that the exponent comes out to be x to the 4th. So now I can fill in my r's with the 6, and now we have the complete setup right there. So this one was just asking us to identify the values that go in those places. So you can see that r would be 6, p would be 4, and q would be 6. And last but not least, find the coefficient of the term in x to the 6. So really the same thing, we're just now using x to the 6 instead of x to the 4th. So I'm going to use the same formula. Just got to plug in the right numbers. So again, I now want my exponent to be x to the 6th. So for this one, what I would do, and there is more than one way to do this, by the way. I'm giving you one method, and I'm using the method that matches our formula packet, which is why I do it this way, because on your test you're going to have this formula to look at, so I want to show you how you can take advantage of that formula. There is another way of doing this, but I'm going to show you the one that aligns with the formula packet that you would have on your test. So anyway, coefficient of the term x to the 6th. So now we're going to say, again, 10 over something. We got our a term to the 10 minus something. You got your b term to the something. So again, in this case, we want to have a 6th power. So that would make this 10 minus 4 in order for that to be true, which makes our r value a 4 in all those locations. There we go. And so the rest is calculator work to get the coefficient of that term. The coefficient just means simply the number in front of x. So once you do your 10 choose 4, we're going to throw that in here real quick so you can see it. So once we do 10 choose 4 times 2 to the 6th times negative 3 to the 4th, that should do it. So I'm going to type in the 10, hit math, go to probability, hit the combination button, and we have a 4 down there. So that's the combination. And now I'm going to multiply that times 2 to the 6th. And multiply that times negative 3 to the 4th. And that should be our coefficient. And I do see on our handout they have a different answer, but the one I'm showing you should be the correct one, because this says x to the 6th, which is what we have in our setup would get us x to the 6th. However, if you look at the one in the worked out solution, they found the one for x to the 4th. So that's why their answer is different. So the directions on this specifically said x to the 6th. So it does need to be the x to the 6th term, which this one is not. So this one that you're seeing on this calculator should be the correct answer.